Right, everyone, I might make a start. Welcome to the third episode in the Brevity Technical webinar series. This short, sharp webinar is on C2 rated seismic anchors and what that means for commercial interiors. So for those that joined last week, thank you for joining back again. It looks like it is working this time, and we've fixed the technical issues we had. So let's jump straight into it. Like the previous two webinars, we'll be using Slido, which is a great tool to add a bit of interactiveness into this presentation. So you can join now by using this QR code. At the start of the presentation, on the next few slides, I've got a few questions just to get a gauge of the audience joining the webinar today. And then the Q&A session at the end will also be done via Slido. So if you have any questions, the best place to put those are in the Q&A, which if you do that QR code, it'll pop up a Q&A session. We'll jump into the first poll. So let's see which part of the country or world even you're joining from today. So if you have that Slido open on your phone, hopefully there's here we go, someone's done Auckland. We have at least one person from Christchurch, Hamilton, Australia. How cool is that? Maybe another from Australia. Oh, maybe not. We'll give it another few seconds to see while some participants are still typing. "31A Drake Street," that sounds like Auckland. Fantastic. It seems like most of the crew today are from Auckland, and it's good to know that we have some members joining from Australia, so welcome. I do have a second poll here, and it looks like some people have already jumped in, which is great. Which discipline best describes you? Are you an engineer, supplier, architect, installer, main contractor, or something else, other? It's quite cool how you can see the live results coming through here. Looks like the majority of the audience are falling into the engineer category. We have some suppliers and perhaps some other. Awesome. All right, let's jump into the presentation. So what the heck has happened? C2 rated anchors, you're hearing, well, I can't speak for everyone, but I'm hearing C1, C2. It's a hot topic at the moment. It pops up in a lot of emails and phone calls, and I suppose what has happened in the last few years. So it's related to post-installed anchors. So what are they? They are used for structural and non-structural connections into concrete. There have been surveys that have shown that anchors for the non-structural elements, such as your commercial interiors, i.e. ceilings, partitions, services, represents around half of the volume of the designed anchors. If you're a supplier, I'm not sure if you agree with that, so it would be interesting to know. And there are clearly lots of different types of fasteners on the market, and they're basically broken down into your mechanical and chemical fasteners, as shown by the few images, example images there. And as a designer, they select the correct type, size, and embedment, among a few other things, that's most suitable for that situation. And just a point to note here, the particular products is not the main focus of this webinar. There are definitely a lot of great products on the market. This webinar is more around what does C1, C2 seismic anchors mean for commercial interiors. So the New Zealand Concrete Standard 3101 went through some recent changes in the concrete standard there, where post-installed anchors shall now pass a European test called ETAG 001 Annex E, it gets into all sorts of fun different codes there, and I won't go down the rabbit hole too far today. But it's clear that concrete anchors now must meet these testing stipulated by the European codes. And well, let's just quickly discuss what happens during an earthquake, the need for seismic anchors. During an earthquake, the structure responds to ground motions and oscillates. Various plastic hinges and ductility definitely plays a part in the response of the structure, and deformation of the reinforced concrete results in various cracking. This can occur almost anywhere and everywhere within the structure and is often closer to the corners. Hopefully the engineers listening today agree with that. So the concrete serves as the anchorage base for these fixings, and those cracks have a significant negative impact or influence on the performance of those anchors, to the point where during an earthquake, a post-installed anchor may actually fail and even fall out in a crack. In reality, as just a side point here, there are lots of other types of concrete structures that don't crack like the traditional crack pattern, and they aren't so crack prone. For example, you've got your post-tension concrete slab, various composite and Confloor tray deck type materials as well. So it's hard to lump everything into one description. But what does this mean for seismic anchors? So there's different anchors are tested to different categories. Traditionally, there's your non-cracked and cracked, and now we're also seeing C1 and C2. And each of these have different testing regimes and results in different capacities for those anchors. For example, C1 is tested to a crack width of about 0.5 mil, whereas C2 is more stringent. It's a larger crack up to 0.8, and I know there's different loading patterns that it's tested to as well. And what does this mean for New Zealand? So the European standards provide selection criteria based on a few parameters. So horizontal accelerations and location are the main ones. And it also, these standards define specific limits, and the Euro codes can be translated to the equivalent New Zealand, like NZS 1170.5 equivalent. And it basically means that C2 rated seismic anchors aren't or should be used everywhere in New Zealand for both structural and non-structural applications. That table at the bottom there just highlights that seismic anchors have very, very varying capacities, and seismic anchors are obviously bigger and more expensive than anchors that were traditionally used for commercial interiors. So what does this mean for commercial interiors? Remember, if you have any questions, you can pop them into the Q&A at the back end. So what does it mean? Let's look at suspended ceilings as an example here. So the concrete standard is referenced in the ceiling standard AS NZS 2785. And so this has become a hot topic for ceiling installers and ceiling designers. So 2785 now states that all post-installed anchors or fasteners shall be suitable for cracked concrete and conform to the concrete standard. Let's ignore the fact that the standard isn't yet referenced in the building code. But yeah, there are a few other grey areas here where interpretation or judgment is needed. So what does it mean there when it says cracked? So is that actually referring to seismic anchors, or is referring to the non-cracked versus cracked? It'll be interesting to see what people think there. And so the concrete standard has made a pretty black and white statement, and that as an engineer can fry your mind a bit, because now engineers are looking for any connection into concrete to require C2 anchors. The regulations have definitely changed, and instead of suspended ceiling hangers that we're used to, we now specify seismically rated anchors that are perhaps 4 times bigger and 10 times more, 10 times stronger than what was traditionally specified. So looking at a suspended ceiling, the 2 main fixings that hold that ceiling to the concrete structure above are your gravity hangers and seismic braces. The gravity hangers are typically installed at 1200 centres along the main tees, and it's common that these gravity hangers are 2.5 mil wire fixed to the slab above and twisted onto the grid below. And the tension capacity of these hangers is relatively low compared to the capacity of seismic anchors, whereas ceiling braces, on the other hand, do need to transfer more load to the ceiling, to the structure above. And those gravity hangers do have redundancy built into their design, where if one hanger fails, the adjacent hangers are designed to pick up those loads. So there's a fair bit happening here, and if we take a comparative view, like if an engineer designs a part to NZS 1170.5 as a part category 7, we don't actually need to stop it falling onto the floor in an earthquake. A P7 part, it doesn't matter what the anchors are as long as it meets the static capacity. So there's obviously a lot more involved in the design there, but where are we going with this? So here are some final thoughts. Particularly if you're an installer, no one sort of hit that box there, but it's definitely important to discuss fixing requirements up front and early, so you don't get caught out after tender. We are aware of many cases there. In our opinion, the industry needs a more sophisticated approach for commercial interiors in New Zealand, and we would propose something like C2 anchors should be used for single point of failure items, such as the ceiling seismic braces, your services, your bulkheads, a lot of those key items. Whereas C2 anchors may not be required for your gravity hangers and items that have redundancy built into it, and items such as your partition tracks that are not suspended. So there's definitely some food for thought there, and it will be interesting to get the comments from everyone else. So now we can jump into some Q&A. So again, if you have a question using that slider, you can pop it in there, and we'll see what pops up. It looks like someone has already asked a question there, so let's do that one first. Are there horizontal accelerations to define when C1, C2 should be used? That's a great question. Yes. So going back to, I don't have it in the presentation here, but going back to the European standards, they classify, they have the location and really your horizontal accelerations, and anything above 0.1 G really is a C2, and I think it's between 0.05 and 0.1 G. That's where C1, C2 could be used. I'd have to have a look at that, and I can always post it in the comments and LinkedIn, a link to the code there to explain that better. We've got another question come in. Can you specify stronger concrete to reduce the amount of cracking that happens, therefore increasing pull-out capacity? Another great question. Can you specify stronger concrete to reduce the amount of cracking? The answer there is, I don't see why not. You could definitely design the concrete to be stronger, the concrete to be less crack prone, therefore less capacity needed in the anchors. And that goes back to, there's a lot of different types of concrete structures. you would expect less cracks in, for example, a post-tension slab versus non-post-tension. So great question. It looks like we've still got people online. Here we go. Another question's popped in. C2 rated required for com floor ceilings as well. That is a great one. So com floor is a composite concrete with the steel underneath. I know there's a lot of guidelines and recommendations from the suppliers going around for the com floor and tray decks. My view there, something's moving around. At the moment, I know C2 are being used for your ceiling braces. It would be an interesting thing to look into the gravity hangers for com floor. So I don't have an answer for that part. I'll have a look into that, and we can clarify that in the LinkedIn post afterwards. Great question. Are there any more coming in? I do. Oh, here we go. Ooh. Where can... I need to be scrolling. There's a lot of questions coming in. Sorry, guys. Tick that. Tick that one. Oh, this is great. There's a lot of questions I didn't see there. Sorry, folks. Threaded rods required to be C2 as well, and for surfaces. Threaded rods is, as far as I'm aware, that would be treated as well. I'm assuming this is a chemical fixing, chemical threaded rod connection. So yes, that would require C2. I've read some literature that's come out recently on that, so we'll put a link in for that. There's a few questions coming in here. Let's look at the last one there. You mentioned C2 anchors should be used throughout the whole building. Is it required by the building code? So that comes down to it's not clear how the European standards relate to the building code. It's obviously there's some references now to the concrete standard now references the essentially C2 anchors. So without any further guidance on that, engineers are defaulting to C2 anchors are being used at the moment. I'll tick that one off. I won't lose these. What do we have here? For timber infill substrates where the thickness of slab is less than the normal requirements, how can we design? That is a great question that I do not have an answer to right now. So I will chat with our engineering team and we will get an answer to that one. Is there a clear definition of non-structural wall partitions as to what is a safety critical application and what isn't? That's a great question. So for partitions, the partition designs themselves are an interesting case where it's not as clear cut as ceilings, where you've got a ceiling standard. Partitions are linked in through 1170.5. So I'm not sure what the safety critical application is. That's another one that I will discuss with our engineering team, and we will be able to respond to that one. Could we use adhesive for gravity hangers? Another good one. So essentially, yes, but adhesive isn't going to fall into the C2. So the questions keep coming in. This is great. I'm going to keep these here because I'm cautious of time. I've got a lot of good questions here that I'm going to clarify at our end to get some answers to, but we will make sure we leave no stone unturned here. We've got, do you expect existing unrated anchors will need to be upgraded, replaced? My initial response to that one is it depends on what was required at the time of the consent. So if a project was consented with before C1, C2 were required, that it will be compliant now, but what happens in the future is a good question. And there's another last question. Well, keep posting the questions and I'll give a full rundown of our answers there. But does the PS1 confirming the use of shot-fired pins override the standard requirements for C1, C2? That is a good one. So shot-fired pins aren't traditionally used now for your ceilings for various reasons. And so if there's a PS1, I imagine that would have been an older PS1 for shot-fired pins. And so for now, the C1, C2 would overwrite that. But yeah, there's a lot of good questions here, a lot of good stuff that we will confirm. And I just had one final question that I was going to throw back to the audience that's still here. Here we go. What about for slab on grade and foundations? Seismic anchor C1, C2 needed for slab on grade and foundations? Let's see what people throw there. It's a 50-50 at the moment. I think that just highlights the current state of the lack of clear guidance here. So yes seems to be winning at the moment. So and some not sures. My take to close out this webinar is for slab on grade and foundations, you would expect less cracks as compared to the structure above. So engineers specify C2 anchors for base plates, i.e. racking structures, to slab on grade and foundations due to a lack of clear guidelines. So that's probably why that yes is hovering slightly more than the no. So turned out that was quite a good slide, I think. So yeah, just wrapping this up, a lot of good questions and participation here. So we will, I'll discuss with the team and get some responses to some of these good questions, and we will post those comments on the LinkedIn page. So keep an eye out for those. And thanks for joining. We hope to see you next time.